Good morning, first period.
Good morning.
It's Friday.
Woo!
TGIF. Yay! All right. So here is. I'm very sorry about yesterday not being here. Oh no! What did I do? I unplugged it. Woo! Deleted. Technical difficulties. The video's still running. That's good. The recording's still running, but I got to get the projector working. All right. So I'll read part of it while I try to get this thing. Hello. Working.
Yes, sir. I'm from the ranch.
Okay. Oh God! Please don't tell me I broke it.
You broke it.
Oh, there it goes. There it goes. I said don't tell me. Don't tell me. I don't want to know. All right. So, sorry about yesterday and the really random notice of, oh, by the way, you have class today. That pulled me out. So, as promised. No.
Bruh.
Oh.
Let's take it
Wait.
over.
Wait. Yes. Yay.
We have light.
Yay. Okay. I'm going to very, very carefully, let me move this desk back just a little, and then
There it is.
all right, part of it is because this thing is, okay, push it in from your bed. Okay.
Okay, so.
All right, we'll try this again. Sorry.
Vine a la escuela a aprender.
Okay, hopefully that works, and I will have to figure out a better method
Whoa, next week.
for getting the cable there to the back, so that way when I need to adjust it, it doesn't. All right, so let me read to you what this is. The title. The title of today's video notes is Third Angles and Exterior Angles. And the topic is I will use the triangle angle sum theorem to discover the third angles theorem and the exterior angle theorem. And so as requested, or as promised, these are the shortcuts. Okay, cross your fingers, cross your fingers, cross your fingers. Okay. All right. These are the shortcuts to helping make those pages 62, 63 go a little quicker for you. All right. Here we go. I'm going to zoom it out just a little bit so that you can see the margin. We have a recall moment. Recall. I'd like to give you a little symbol to help you recall. Gentlemen. Thank you. I'd like to give you a little symbol to help you with the recall. Let's use a little like recycle symbol. So it's like a circle with some arrows in it. Okay? It's like a little recycle. Okay, so I'm not the best artist in the world. I'm sorry. It's like the recycle, reduce, reuse, recycle, because we're recycling information. And I want to recycle the triangle angle sum theorem. Do y'all remember what that said?
Yeah.
What did it say? I remember it, but I have no idea what it said.
The triangle theorem is?
Yeah, the triangle angle sum theorem.
Can we look back at it?
Of course you can. $180? She says.
180. Yeah.
180?
180.
Yeah, 180. You went to your notes, and then everyone else was like, "Oh yeah, I remember it now."
It was 180.
It was 180. There it is.
Here it is.
So we're going to start off with that recall. So I'm going to put a highlight bar on that whole thing. Okay. It's just a recall moment. So it's kind of a little separate from the rest of the notes today. Only by a little bit. Just a little bit. All right. I'm going to give you the name of the theorem. We're going to write it out, and then we'll do an example that uses it. Okay? So here's the name of our first theorem today. The name is important. It's the third angles theorem. Here's what the theorem says, and then we'll use the triangle angle sum theorem to figure out why it why it works. Okay. It says, if two angles of one triangle are congruent to two angles of another triangle, then the third, oh, I spelled that wrong. There you go. Then the third angles are congruent. Sorry for my spelling. So you have a ruler or a straight edge, and you want to draw your triangles nice and pretty. Now's the time, or you can just freehand your triangles. That's okay too. Freehand them. YOLO!
Oh my god, she's so cool.
I told you that story about my daughter, right?
Nope.
And the rain.
Nope.
It was raining the other day, and I was like, hurry, get in the car, throw your stuff in the trunk, go fast. And she goes, okay, Mom, I'm going to YOLO it. I was like, okay. All right.
Oh, that came up.
All right. So here's now it doesn't have to look exactly like mine. Yeah, she's a first grader. Yeah.
See you, YOLO?
All right.
What is this word coming?
So here's the example. We're told if angle 1, so here's angle 1, is congruent to angle 2, here's angle 2, find the measure of angle 3. And angle 3 is right here. I'm told that this is a right angle, and I'm told that the measure of this angle right in here is 32 degrees. And that's the only information I'm given. Okay. Let's use this example to show you that these two are congruent in y before we just say, oh, look. Right?
What does that say up there on the top left where the arrow is?
This?
Yeah.
32 degrees.
32 degrees?
Yes, sir. All right, so I'm going to do some markings. Angle 1 congruent to angle 2. So there's some congruent angles. Because this is 90 degrees, this is also 90 degrees. 90 degrees. So I can figure out what this angle 1 is supposed to be, can't I? Right here on this triangle on the left. Because I have two of them that I know. And there's one that I don't. So I'm going to call this one triangle A, just to keep things neat. This will be triangle B. Remember, we're just giving names to things, so it's easy to talk about. Looking at triangle A, look, triangle A, the measure of angle 1 plus 90 plus 32 equals 180. Right?
Yes.
Nothing too weird. That was the triangle angle sum theorem. Gonna write the reasons in blue today. Blue! That's my boy, Blue.
Okay.
Hey, let's subtract all these numbers, all right?
Okay.
Okay, so,
Okay.
oops, not there, over here. So measure of angle 1 plus 32 equals 90.
Yes, sir. From the range.
Subtract 32.
It's
32.
no way.
Hut. Oh my goodness. 50, 52, 50. Someone get a calculator, please. Do it. 90 minus 32.
58.
58. Where did I get 52 from?
From the 2.
Oh, yeah, from the two. It's exactly. All right, so this angle now we know is 58 degrees.
Sí, señor.
We know that angle 1 and angle 2 are congruent, yes?
Yes, they're 50 degrees.
So
Yes.
this is also 58 degrees.
Yes, sir. I'm
Which means what does angle 3 need to be? This the same? So it's also 58?
no.
It's 32? Not just because of the theorem, but the theorem is because, look what we have here. We have two angles in this triangle, and we have these two that we know in this triangle. They all need to add up to 180.
Yes,
So
sir.
if these two are the same, then these two got to be the same. Make sense?
Yes, ma'am.
All right. Let's give you the next shortcut. The name of the shortcut is important.
Ooh, that
It's
sounds important.
it's called the exterior angle theorem. We'll write the theorem, and then I'll do a little drawing so that you can see the different parts of the triangle that you need to have.
Así no, así no.
The measure of an
Yes, sir.
Shh. Exterior angle of a triangle is equal to the sum, that means add them together,
Oh.
of the measures of its, the triangles, two remote interior angles. I want to automatically clarify one word for you. How did you know? It's like a remote control.
Oh.
Remote control allows you to control things from far away. So remote here is meaning the same thing. It's the far away inside angles. Ooh. All right. Going to draw a little picture. I'm going to do it here. Wait. No, do it here. To show you where the interior and exterior angles are. And then we'll do an example in this space. Okay.
Nice.
All right. So if you want to divide your workspace a little bit, that would be okay with me. Okay, this is going to look like a hot mess. It looks weird. Kind of crazy, huh? These angles right here are inside the triangle. So they are the interior angles. The exterior ones are the ones that create linear pairs with the interior angles. This one creates a linear pair. This one, oh come on pen, is an exterior angle. This one creates a linear pair. It is also an exterior angle. This one creates a linear pair. And this one creates a linear pair. They are also exterior angles. This one creates a linear pair. And this one creates a linear pair. They are also exterior angles. Notice that there is a set of angles that I did not include.
Yes, the like acute angle.
Yeah, the ones that are vertical to the interior. In this case, they don't have a name. They're just vertical to the interior. We're not going to consider them when we're talking about interior and exterior angles.
What kind of angles are there?
It depends on your triangle. Some could be right, some could be acute, some could be obtuse. I don't think you're ever going to run into a straight
Is there like an actual
one.
name for them?
The ones that are red?
Yes.
The vertical angles to the interior. Yeah. Not a formal name, but more of a description.
Gotcha.
Yeah. All right, so let's run an example so we can see how this thing works. Let's do a quick show of thumbs. Thumbs up, you have gotten into page 62 and it's breaking your head. It's breaking your head. You're in it and you're looking at it and you're going, this is a hot mess and I'm so lost. Okay, good. That's about half. You got the rest of you who didn't and aren't on 62 yet.
Oh, I'm raising my hand. I'm calling you, man.
Oh, what?
I would say I'm still on 63.
You're on 63. Okay, good job. Good for you. All right.
I'm 95.
Let's draw one that kind of looks like one of the ones that you were seeing on 62. So you were probably seeing something along the lines of this, yeah? And you were asked to find this measure, because the direction said find the value of x. And you were told this number and this number. Right?
Yes.
Keep the side conversation to a minimum, please, ladies. Thank you. And that's all the information they gave you. Well, those of you who are struggling with it hopefully saw that, yes, you may be missing that angle right there that I marked with a blue letter Y, but with your triangle angle sum theorem, you could figure out what that value was. And then using the idea that these are a linear pair, you could figure out what this one is. Right? So let's run that really quickly so that you can see what it might look like. There are the two angles in the triangle that we know. There's the third angle of the triangle that we don't know.
60.
Just catching up with my numbers here. And this means that y is 60. But take a look. Over here, in the variable that we are interested in, this x, if we add x and y together, we're going to get 180. Take note. Look right there. You see how similar those two phrases are? So looking at just this two lines, what must be the value of x?
120.
120, which came from the addition of the other two angles, the remote interior angles. This is your shortcut.
So you're saying in all cases, the addition of the other two angles are going to be
Yes.
x in this case?
Going to be whatever the value of this is.
Always.
Yeah, always.
Bro.
For real, for real, for real.
For real?
Of villas.
Yeah, it's
Always.
short. It's like a shortcut.
Super, super shortcut. It works even if you're given weird gobbledygook. Okay? If you're given a lot of letters here, letters and numbers here, and letters and numbers here, this idea still works. That the measure of this angle out here, the measure of this angle out here is equal to the two far away inside angles added together. That's it. Those are your shortcuts.